Okay, now let's do problem 4.9. The service life of a battery used in cardiac pacemaker is assumed to be normally distributed. A random sample of 10 batteries is subjected to an accelerated life test by running them continuously at an elevated temperature until failure, and the following lifetimes in hours are obtained. The manufacturer, part A, the manufacturer wants to be certain that the mean battery life exceeds 25 hours. Conclusion can be drawn from these data. Use alpha 0.05. Part B, construct a 90% two-sided confidence interval on mean life in the accelerated test. And part C, construct a normal probability plot for the battery life data. What conclusions can you draw? So first, let's start with part A. Let's go and read the question one more time. We have the data. The data is basically no information about the. Okay, so as we notice here, no information about the population standard deviation or variance is given. So therefore, we are going to rely on all our information on the sample. So first, let's start with number one. Nu is equal to 25, and as we notice, the alternative, excuse me, the alternative is one-sided. It is equal greater than 25. Okay, because here it says that exceeds 25. So this is how we know it is greater than 25. So number two, state or use the appropriate test statistics. So in this case, we are going to use T naught, which is equal to x bar minus mu naught divided by s divided by square root of m. Now, why did I use the the t-test? Because simply the variance or the standard deviation of the population is not known, and we are going to rely on the sample. Okay, on the standard deviation from the sample. So x bar now, I already calculated x bar, and it is equal to 26. Okay, so minus the hypothesized value 25 divided by s. Also, I calculated the standard deviation. It is equal to 1.625 divided by square root of n. N is equal to 10, so square root of 10. So now the test statistic that we have is basically 1.95. Okay, now based on alpha, we have a one-sided. So let me, this is the t-test. Okay, it is a one-sided and greater than. So my rejection region will be only on one side. And this will be my critical value. I will have only one critical value. So it is T alpha. Now it's T alpha, not alpha over 2. Okay, so it's T alpha and with the degrees of freedom n minus 1. So this is equal to T 0.05. Degrees of freedom is n minus 1, so it is 9. Okay, so we get this from the table. So let's get it from the table. So this is now is a one-sided. Alpha is equal to 0.05, and I have degrees of freedom is 9, so my critical value will be 1.85. If you can see it, 1.833. Sorry, it is 1.833. So go back here, and we write this 1.833. Now the test statistic is 1.95. 1.95 falls in this region here. So this is my rejection region, and this is my acceptance region. Okay, so it falls in the rejection region, not very far away from the critical value. However, it is in the rejection region. So therefore, Going back to number 4, about what conclusion can be drawn, we can draw that the conclusion we can draw is that yes, indeed, since since T node falls in the ejection region, we conclude that we reject H node, and therefore the mean battery life, the mean battery life is greater than or exceeds 25. Okay? Now to construct a 90% two-sided confidence interval. So let's do this here. So I need to construct a two-sided confidence 90%. So this is now x bar plus t alpha over 2, because it won't let me, yes, two-sided. So it is alpha over 2, and with the appropriate degrees of freedom. And from the other side, S over square root of n. From the other side, now we have x bar minus t alpha over 2 with the degrees of freedom multiplied by s square root of n. So now this is u is 26. This is the average from the sample, t alpha over 2, and we want a 95 confidence interval. Again, since this is a 90%, so therefore alpha over 2 will be 0.05. So I'm going to use the same value here. So this is 1.833 times the standard deviation. Standard deviation, the sample standard deviation is 1.625 divided by square root of n. Square root of n is basically square root of 10 from this side. And from the other side, we are going to use, again, 26 minus 1.833 multiplied by 1.625 divided by square root of 10. And I leave that for you to calculate. Okay?